quadratic. In the shot put, if an athlete throws a heavy metal ball through the air, we know what shot put is, right? Does anybody here throw the shot put? I know Michelle Elias does. Have you before?
Yes.
Okay, so you know it's like the, and it actually is like the perfect quadratic, especially if you're talking about height off the ground. This one's a little different. You can use this equation, 0.04x squared plus 0.84x plus 2, where x represents the horizontal distance that the ball has traveled, and y represents the height that the ball has moved, going up and down in the air. And this question, if you're trying to figure out how far from the athlete the ball would land, you really want to figure out when that ball crosses the x-axis, when the quadratic would cross there, which would represent the solution. So if I wanted to use the quadratic formula for this equation, what values would I substitute in? First, we need to identify what are the A, B, and C values of the equation. The A value is represented by the 0.04. And some of you on your DOL from the other day, which I will hand back, we're using the x variable in addition to the 4. But if we have our quadratic in standard form, you can see here that A value is everything except for the x squared. It's the coefficient of our x squared. So our A value is our 0.04. What's our B value? Yep, 0.84. And our C value is 2. This 2 over here. Jump to the next line. Not what I want. Okay, it's that 2. So if I wanted to substitute into my quadratic, what would my equation be? Negative. Hold on, let me move that. I wanted to move that. There we go. 0.84 plus or minus
0.84.
Good.
Just 4 parentheses.
Good. All over 2 times 0.04, which some of you missed that A at the bottom. And you mentioned it, and I was grading, I saw it. Now this type of question, you would have a calculator. You would not be expected to calculate a quadratic like this without a calculator. Okay? But this problem, and actually I'll scroll back, this is a little unrealistic of a problem to factor. Completing the square may be extremely time consuming as well. So this example, like what jumps out at you when you see this that makes you think I'm probably just going to use the quadratic formula? What about the equation might indicate that the quadratic formula is the best bet here? Yeah, decimals are a big one. Think about when we learned how to factor a quadratic. We weren't really factoring decimals. That might be extremely time consuming. Also, if you are to complete the square, the process might be a little daunting if you're dealing with decimals. So this example might indicate, I think I'm going to utilize the quadratic formula. Now there's reasons why we would use all of the types of solving that we have learned up to this point. So here are the methods that we've used. We have learned to solve a quadratic by graphing, by finding square roots, by factoring, by completing the square, and by using the quadratic formula. So this is a good guide. If you have looked at a quadratic and thought to yourself, I'm not really sure when I should do this method versus when to do another, this is a guide for you. So take a moment and write these tips down. And most students struggle with this. As an adolescent, there is a lot of research that says too many choices are not necessarily a good thing. And this would be one of those examples. Like there's 5 ways that you can solve a quadratic equation. And it might feel very overwhelming. Some of you may feel overwhelmed when you see a quadratic and think, I've solved so many different ways, I don't know which way I should solve this one. And this is a great guide. So the first way that we solved a quadratic, way back at the beginning of the unit, was by graphing. If you have a graphing calculator, this is a great option. And I know it's kind of silly. We are going to use the graphing calculator. We're going to take them out next week so that you can see how to utilize them, what they do. The calculator on the park is a graphing calculator. So before you take that, you're going to have experience with the graphing calculator. And a graphing calculator is wonderful because if you are given the quadratic, you could very simply just type in the quadratic equation and hit a little button. And when you hit a button, the graph is animated for you. And then there's a function there that you can hit another button and see a table of all the values. And you can identify the x-intercept on the table. Great option if you have a graphing calculator handy.
So they're giving you the answers?
You'd be able to identify the answer on the calculator. Next week you'll see exactly what I mean, whether you see it in the image where the lines cross the x-axis, or if you go to the table version and see the values of the table. Now that doesn't mean on the park that they're not going to have you graph a quadratic without a graphing calculator, but it would be a more basic quadratic. They also may show you a graph and ask you something about the graph. Maybe the vertex, or where is the y-intercept, or the solution just by observation. After we learned to graph a quadratic, we started to solve them by finding square roots. And the most important thing about these quadratics, they didn't have a bx term. An example of this would have been something like x squared minus 9 equals 0. There's no bx term here. This is just the ax squared plus u and the c value. And because I only have one instance of x there, I only see x at one time, I can isolate and solve. So if you have an equation in that format, finding the square root is a great option. After we found the square root, we started to factor. This tied in a lot to our last unit because our last unit, we really focused on factoring quadratics. We took it one step further and solved using factoring in this unit. And you would want to factor if you're able to easily factor the equation. And that might be different for some of you. Some of you may feel really comfortable factoring a quadratic if there's a coefficient of 1 with the x squared, or if there's a coefficient different than 1, besides 1. Some of you might feel a little bit more comfortable there. At first glance, you may be able to identify the factors right away. That would be one you can just factor and move on. After we factored to solve, we started to work with completing the square. And we didn't only solve quadratics by completing the square. In addition to solving, we completed the square to transition a quadratic from standard to vertex form. So you can use completing the square to solve, or to just put your quadratic in vertex form. Now, if the coefficient of x squared is a 1, but you can't figure out what the factors would be, you can complete the square. And it doesn't mean it's not factorable. Like maybe you just can't figure out what the factors are. Completing the square would still work. We did practice a lot of examples with completing the square of quadratics that were factorable. You'd get the same answer. Now, we also practiced completing the square if there's a coefficient besides 1. We did practice that a little bit. And you could do that. But at this point, because you know the quadratic formula, you may not even want to take the time. If you can't factor easily, or you have a quadratic that's different than 1, you could opt to utilize the quadratic formula. Quadratic formula tends to be a lot, I don't want to say easier, but I'll use that term. Quadratic formula tends to be easier when a calculator is handy. But there will be questions on the non-calculator section of PARCC that have you solve quadratics. I feel like most of those will be factoring, completing the square where it's a whole number, maybe even a basic quadratic formula where it's not going to end up being a crazy fraction or decimal. Now, you do have the ability to find the square root of a number to the nearest tenth. Okay? I can't imagine that it would be a crazy quadratic, but there may be some where you don't have a calculator that they want you to specifically use the quadratic formula. So what we're going to do is on the next slide, I'm going to show you 5 equations. And all you're going to do is take like a minute or two and figure out which method you would use to solve. There's no right or wrong answer here. It's how you look at the equation, what you think about it. Because now what's going to happen is you're going to see some on the PARCC especially where it just says solve. And you, in a relatively quick amount of time, have to determine what method should I do. But it also, if you try a method and it doesn't work, that doesn't mean you just stop and say, oh, there's no solutions here. You may have to try something else. So take a moment with these 5 and just jot down in your notebook what method you would use for each one of these, for A, B, C, D, and E. Take like a minute or two. Just take a look through which method would you do. And we'll talk about why we chose the methods we chose. Who wants to share what method they think makes the most sense for option A, or for equation A? Yeah, finding the square root makes a lot of sense here. Why do you think square root? Yeah, if there's no b term in this situation, I could isolate x pretty easily. I could add 9 to both sides, divide by 3. That would end up being x squared equals 3. Even though it's an irrational number, you could find the square root of 3 and estimate it to the nearest 10th. Okay, so square root would be a great option here. How about b? What are we thinking for b? Completing the square. Okay, did anybody have anything different? Yeah, factoring would be a good one as well. Now, when you take a look at these, if you can easily identify a factor, then absolutely go that route. Some of you may have looked at that and thought, what are factors of negative 30? That would add up to negative 1. If you're going through the factors in your mind, some of you may have jumped to knowing that 6 and 5, if you multiply a combination of them, would give you 30. I think I might be able to get a 1 out of that. If you're going through, like you broke out the factors and you just missed it, like you just missed 6 times 5, gave you 30, then it's okay from there to complete the square. Because if you have one that doesn't factor at all, your next option would be to complete the square. Good. How about C? Completing the square? Okay. Any others?
Quadratic formula.
Yeah, I probably, just if I were doing these problems, I would probably use the quadratic formula there, only because completing the square is a challenge when you have coefficients besides 1. Think about what we need to do if we complete the square here. We would need to add 17 to both sides. But then, with the 6x squared plus 13x, I would need to factor out a 6. I can't factor a 6 out of 13. That would be a problem. So then I'd end up having to divide out, and it would be a little bit more time-consuming than I'd like. Knowing that my numbers 6, 13, and 17 don't factor easily, I'd probably jump to the quadratic formula. If you tried to complete the square, you would have to divide out somehow to go that route. That might be a bit of a challenge. How about D? What do you notice that for, even though the numbers are relatively small, the constant is 3, the coefficient of the B term is negative 5. What do you know when you just look at first glance if you tried to factor? It's not factorable. There are not factors of positive 3 that would combine to give me negative 5. So what would my option be? My next, yeah, completing the square would be a great option here. What else could I do? Yeah, I could use the quadratic formula as well. This one may not be too bad with the quadratic formula. This is just my assumption, don't quote me, but if you had a question like that, I would assume that would be in the non-calculator section. Like I don't envision you getting a calculator for that one. Even if you were to complete the square, that would be where you would find the square root of a number. Again, not a crazy number, but where you would estimate it to the nearest 10. How about 8? I like the quadratic formula for that one as well. You try to complete the square there. Might be challenging depending on how you factor out that negative 16. But I would say quadratic formula is a great option here. And just real quick, just look at the screen. Those are all different types of quadratics, and they can all be solved a different way. And that's what we're going to try to focus on as we move forward from here to the park exam. When should you use certain methods? And it may be different for all of you. Some of you might be really comfortable completing the square. You may opt to complete the square instead of factor, even if it's factorable. A lot of this does become preference. Now, up until now, when we were completing the square, we did it to solve. We also did it to transition our quadratic from standard to vertex form. When we first learned the quadratic formula the other day, we learned how to use it to solve. Today we're going to talk about another reason why we would want to use the quadratic. A quadratic equation can have 3 types of solutions. This we have talked about. You've seen an image of it. They could have a quadratic could have 2 real number solutions, 1 real number solution, or no real number solutions. Before you solve the quadratic at all, you can identify if there will be 2, 1, or no solutions by using something called the discriminant. So this is the discriminant. And I'd like for you to write pretty much this whole page. The discriminant is the expression underneath the radical sign in the quadratic formula. It's this b squared minus 4ac value. That is the discriminant. And when you calculate, it could be a positive number, a negative number, or 0. Now, on the park exam, you are given the quadratic formula. You are not specifically told that that is the discriminant. So that is something that you would need to remember. You would need to remember the word discriminant and what it refers to. We will practice with it quite a bit until the park, so you'll have a little bit more familiarity than just today. So if you saw a question on your park exam, or if you just needed to identify how many solutions a quadratic had in a quick way, you could utilize the discriminant. We're going to go through some examples here of how we would do that. Can I slide to the next slide, or somebody still waiting? We're a little crunched for time, I know. So what is the discriminant of that quadratic? If I know that it's everything in the radical, what would I substitute in here? Negative 6 squared minus 4 times 1 times 7. And what does that calculate to?
36.
36 minus 28. So, and that's the square root of 8. I heard somebody say it. So here, our discriminant is a positive number. If after calculating my discriminant is a positive number, there are two solutions, two real number solutions to my quadratic. So the discriminant being positive results in two real number solutions to my quadratic.
You write that down.
Yeah, write that down. And even though it would be a little bit of a process to find the square root of 8, imagine doing the entire quadratic formula there. After you find the square root, you would have negative b plus that square root of 8, negative b minus that square root of 8. You get a number there, a rational number. You would get that, and you could continue to calculate. You'd end up with two answers. So if your discriminant is a positive number, your quadratic has two solutions, two real number solutions. Just based on that one alone, you could probably think about and figure out what the other two would be. But we're still going to go over them. So our positive discriminant represents two real number solutions. And you don't have to write down every single calculation here as long as you know that b squared minus 4ac is the discriminant. You'll be able to make those connections. Can I stop? What would I do for this discriminant? Negative 6 squared times 1 times, which is what? 36 minus 36. So I'm dealing with the square root of 0. What do we think? One solution. If our discriminant is 0, I have one solution. And think about what happens if I had negative b plus the square root of 0 or negative b minus the square root of 0. That ends up being the same calculation because the square root of 0 is 0. So that's where these both would be the same number after I calculate. My quadratic would have one answer. You'll see examples of that. But if your discriminant is 0, then your quadratic would only have one solution. And if you actually calculated that out, the solution is 3. That is factorable. So there are factors there. X would be 3. That's only one solution. If your discriminant is 0, you have only one solution. So positive discriminant, two solutions. Discriminant of 0, one solution. We'll see the last example. What would I plug in as my discriminant? Negative 6 squared minus 4 times 1 times 11. So this simplifies to the square root of 36 minus 44, which is the square root of negative 8. If my discriminant is a negative number, there are no real number solutions to my quadratic. Why not? Yeah, the square root of a negative number is a non-real number. So if my discriminant is negative, I have no real number solutions. Positive discriminant, two solutions. 0 as a discriminant, one solution. Negative discriminant, no real number solutions. And on the next slide, I'll show you an image to put it all together. You're still writing things down. This isn't all together. We already know what it looks like to have two solutions, no solution, or one solution to our quadratic. But this shows the same calculation we just did. This positive discriminant graphed, this actually has two solutions. This discriminant of 0 graphed, it only has one solution. This discriminant of a negative 8, there are no solutions because my quadratic never crosses the x-axis. And you may see a question that says, how many solutions does this quadratic have? You could very quickly calculate b squared minus 4ac, and identify if that's a positive number, 2 solutions. If it came out as 0, 1 solution. If it came out as a negative, no solutions. Is anyone still? No, you don't have to. This really is a summary of everything you've written from the other couple of slides. The reason I was sitting on this one a little bit longer was if anyone missed anything from the previous 3 slides. It would be here. Heads up. Is anyone still writing, or can I advance? So this type of example, what would I need to do in order to figure out how many solutions that quadratic had? Okay, I can find the discriminant. What do I want to make sure of before I start calculating standard form? Yeah, I really want standard form. Why? Okay, so not only that I need one, but what about I need to know what it is. Right? I need to know what the A value is, what the C value is, and what the B value is. So what would I have to do here? What is my equation in standard form? Yeah, I can add 5 to both sides. So my A value is 2, my B value is -3, and my C value would be 5. From here, I can actually find the discriminant. Let's find the discriminant for this one. What would I calculate? -3 squared minus 4 times 2 times 5. I'm sorry, I had added this on the previous slide, so it would be a positive. This becomes the square root of 9 minus, so -4 times 2 is -8. -8 times 5 is -40. What's my discriminant here telling me? So what does that mean for my quadratic? It has no solutions. Because that number is a negative, this quadratic would have no solutions. Let's try one on your own. How many would that have? And this may not take you that long. You're not going through the entire quadratic formula. You're just using that discriminant. So this might only take you about a minute. What is the discriminant telling you here?